No, well, let's wait until some more people come in, and then we'll introduce. We're almost ready to roll. Okay, I think we are. Sorry. Good morning, everybody. This is Ian Williams, President of the Foreign Press Association, who's gasping through the heavy pollinated atmosphere of New York. My throat acting strangely. And it gives me a great deal of pleasure to introduce Laura Mercini Houghton. Did I get the pronunciation right?
Yes, yes.
Okay. I'm British myself, so I should get Houghton right, but you can never tell.
Yeah, well, I think you're from the same town as my husband, Liverpool?
Yes.
Yes, yes. So it's Houghton there.
Oh, wow.
But most people pronounce it Houghton, so it's fine.
Yeah. Well, so Laura Mercini Houghton was brought up in Tirana in Albania in, I would like to say the dying days, but the dying days took a long time of dying, of Enver Hoxha's eccentric regime, in which the universe ended at the Albanian border pretty much for most Albanians, and even more constrained because her father was a denounced political dissident who spent a lot of time incarcerated or in exile, but they still had an education system that functioned. And I don't know, was there a party line on the Big Bang? Was there a party line on on the nature of the universe and the red shift? But what impressed me was that incarcerated or in exile, but they still had an. Hello, I've got an echo there.
Okay.
So,
yes,
I will start again.
Okay.
So, I'm Ian Williams, President of the Foreign Press Association, and I'm speaking to Laura Merton Houghton, who came from Tirana to the University of North Carolina. Was it? No, it was not the University of North Carolina. He came from.
It was the University of Maryland at College Park.
Right. So this was a huge expansion of the universe for Laura, obviously. Her father was a political exile. Her movements were constrained. Leaving Albania was the edge of the event horizon for most Albanians at the time, since Enver Hoxha ran a very tight ship, more like a galley with slaves in it rowing hard. He managed to alienate. Just to remind those of you who don't from these days, Enver Hoxha first of all fell out with Tito and started hostilities with Yugoslavia. Then he fell out with the Soviet Union and started hostilities with China. And then he fell out with China and pretty much started hostilities with everybody. So it's a fairly constrained intellectual and political atmosphere in which Enver Hoxha, who put his selected works in storage somewhere, had theories about almost anything. But how did your upbringing get into cosmology? Was the Marxist, Leninist, Hoxhaist education system at all inclined towards cosmology, or was it something that you picked up inadvertently?
No, natural sciences were probably the safest compartment in the Albanian society that was not infected by politics. So that regime had very little to influence on math or physics and so on. The reason I ended up a physicist and a cosmologist was mainly because early on I was inclined to natural sciences. I was naturally good at math, physics, biology. I wasn't good at anything else, especially social sciences. So it just happened naturally. And my father was a mathematician, and that although he never told me what to do and what topic to choose, but just our conversations every day must have been inspiring and drew me even deeper into how beautiful mathematics is. And of course, theoretical physics is very closely related to mathematics. So I knew early on that I would be studying science in Albania, and from what I've seen and known since the Berlin Wall that changed that part of the world, the whole Eastern Europe, in Albania and in all the Eastern European countries, education was a very important component of the society. And the reason was straightforward. If you think of communism trying to advertise that everybody is equal, independent of their skill, merit, capacity, work, and so on. So you're trying to fit everybody into a shoebox, and then that goes against human nature. We are different, and that's the beauty of the human species, that we have different talents, we have different interests, we are good at certain things and not good at other things. So in a society as crushing as a dictatorship, it becomes even more important. It is a driving factor to every human to try and find ways to distinguish themselves, to differentiate themselves from being the same, from that sameness that the society imposes on you. And that's why education was really the only available tool for people in Albania, and I'm sure in other communist countries at that time. Education was the way to try and raise yourself above that level of mediocrity. So education was very important in Albania. Social sciences were heavily influenced by politics. Of course, that's where you could err and where you had to embrace the party line of Albania being the best country in the world and being the center of the cosmos, and how all the other countries suffered so much and were exploited so much that there was no point on being interested in them. That was the propaganda that the Communist Party and Hoxha were selling at the time. Of course, nobody believed that, because whenever you try to impose your will upon people, then people react against it. However, if certain people work, I don't know, in political sciences, in law, in history, which was a bunch of lies in Albanian times, then of course you couldn't move too far out of that party line, because then you get yourself in trouble and in jail. There was a certain freedom in natural sciences. So in that sense, the Department of Natural Sciences, physics, biology, chemistry, and mathematics were very strong even in Albania.
Well, you've become one of the world's most innovative and prominent cosmologists with your recent work, which we'll get back to soon. But people might forget that Albania was the first official atheist state in the world. All the churches and mosques, and presumably the synagogues and chapels, were closed down. So did this influence the cosmology that they taught, a sort of creator-free cosmology, or was that ancillary to your studies?
I didn't learn cosmology in Albania. Albania at the time when I was growing up didn't have a graduate school in physics, so I couldn't move to more advanced studies. We only at the undergraduate level at the Faculty of Physics. So in that sense, no. The fact that Albania was an atheist country did not influence me. I did all my advanced studies in the US. I've spent more time in the US than I spent in Albania. But the religion part in the Albanian society is quite an interesting component. So perhaps at some level, inside me, there is some influence, like in all the people that were born in Albania. And I say that because, yes, when I was born and I grew up, and the whole generation of Albanians then and that are still living now, they were born and grew up in a completely, strictly atheist society. So my knowledge of any religion is very ignorant, in fact, and that's a gap in my education. But even before then, before when before communism took over, when Albania was under the Ottoman Empire, was invaded by the Ottoman Empire, and before then it was under the Roman Empire, and before then it was under the ancient Greek Empire. So always religion, and it's a very old nation. It's pre-Greek and pre-Roman, and it used to be bacon in those days. So any kind of religion that moved to Albania at some point in history was always associated with an invasion. And in that sense, although Albanians are probably the most tolerant people religion-wise that I've come across in any country in the world, they are open and welcome and embrace all kinds of religions, but not a single religion really stuck deeply in Albania because of that association, that it was always foreign brought. It came to the country along with boots on the ground.
Yes, I remember a trip to Tirana after the fall where I saw somebody with a green turban and robe and discovered he was a Bektashi monk. And I thought he was my type of Muslim monk because he had a glass of whiskey, he was smoking a cigarette, and he was talking to an attractive young lady at the same table. So I thought, if this is fundamentalism, I can live with this.
Yeah.
So I got the Episcopalian nature of Albanian Islam at the time.
Yes, and then the bottle of grappa in front of a mosque or a church, yeah.
But so Robert Papa wants to know, do you think the Albanian education system helped you to be at this level? I mean, was there a special concentration on the natural sciences and an encouragement of it that got you this far?
As I said, when we started, that was one of the components, but there are so many factors. I mean, a key component is the fact that I got so lucky to have the Fulbright scholarship and move to the States where I could access the higher education. Having a strong background at the undergraduate level from the Faculty of Sciences in Tirana certainly helped. Otherwise, I'd not have reached the point of moving to the graduate level. Having the father that I had, who was so encouraging without being pushy, and who introduced me from when I can remember, from 3 years old onwards, to the beauty of these big questions about nature, science, mathematics, and the beauty he saw and found in the equations that he shared with me, and then the beauty of going for a stroll together in the evening and looking up at the night sky and then just finding the whole universe and any deep question about the cosmos so inspiring, that was something that I shared with him, and that only encouraged me further. So it's not one unique component, whether it was the education I got in the Faculty of Natural Sciences in Tirana or the graduate school at the University of Maryland, and then later on working with Leonard Parker for my PhD, and he's a world authority in quantum field theory in curved space-time. So there is a blend of many factors that led me to where I am today.
Well, this brings us to your book, because one of the things you managed to interweave, I think, very successfully and make it much more readable, is the hard theory of the history of the universe from before the Big Bang to after the Big Whimper or whatever, to interweaving it with your personal life. And your father comes across as somebody, he wasn't, my father, if he spoke to us at all, addressed us as though we were a public meeting. But yours seemed to be more concerned about providing a nurturing educational environment and encouraging and helping you look further. He's obviously played a large part in your life, but this is where you may as well come up with the book.
Yeah.
This is Laura's book, which I read very shortly. I mean, I've got to compliment you. This is a book by a mathematical physicist about the nature of the universe, and you achieve the equivalent of an Italian making a speech while sitting on their hands, because you introduced almost no mathematical formulae in there. I was like, the math is there, but it's described. It's not shown off. And for most lay people, even interested lay people like myself, there's nothing more off-putting than a page or a line of equations and mathematical formulae. Your formulae are sort of pretty much on the comprehensible equals MC squared style, which even I can remember. I've forgotten how to factor a quadratic equation, but I could probably remember if I tried. But E equals MC squared, I can manage, and you did this. So, I mean, the key part of the book and what's got your reputation was your discovery that there are ways to know what happened before the Big Bang. And perhaps you could explain to people why it is that until then, nobody thought we could find out what happened before the Big Bang. Just as before Stephen Hawking came, we had no clue what was happening inside a black hole. But there are tangential clues which he discovered on black holes and you discovered on the Big Bang. Can you explain this?
Yes, certainly. So until recently, the law in the field was that we have this universe, only one universe that started as a very small patch full of energy, and it grew up pretty quickly into the large universe that we see today. When I say pretty quickly, I'm talking as a cosmologist. So pretty quickly for me is 14 billion years. But in that sense, the whole description of what we see around us, the structure formation, all the galaxies and the stars and the planets, the light, the radiation in the fabric of space-time known as the cosmic microwave background, which is a leftover of that early moment when our universe blew up. All of those seem to fit perfectly well with this beautiful picture of cosmic inflation. As science moves forward, we collect more data, and all the data also seems to agree with that view of starting with this universe, very small, not long ago, that blew up, and the quantum fluctuations of that early energy are the ones that later on condense and create all the structure that we see. That fits beautifully well. And then you may wonder, what's the problem? If we have a theory and we have the data that backs it up, then we should be happy. We are done. But we're not done. And that's where one of the giants of physics, Sir Roger Penrose, estimated and pointed out in the 70s. He estimated that the chance to start with the universe like that one, where you have a small, smooth patch, like extremely small, full of energy that blows up and creates the universe, that chance is nearly zero. He estimated it's one chance in 10 to the power 10 to the power 123. And Roger and I have debated this issue quite a bit over the last decade or so. And in the last debate we had 4 years ago, he corrected me. He said, if you include dark matter, it will be to the power 124, not 123, which of course doesn't make a difference. It's still zero. And that's the ill-famous problem of the origin of the universe. How can such a simple picture that explains so much of what we see around us be so unnatural, have zero chance to come into existence spontaneously? And then the community was divided since the 70s in two groups. There was the group of naysayers that said, no, we've really not got a problem. That's nothing to worry about. We'll never know what was there before the Big Bang, or if there is such a thing as before the Big Bang. Perhaps we started with a singularity, like what you have in the center of a black hole. So there is nothing we can do about it. All our physics theories break down there, so we can't go further. And then there was another group, the curious ones, that were like, hold on a minute, we can't put a curtain of prohibition there and say, this is it, we won't ask questions any further. That just goes against the nature of a scientist. We don't want to be limited in our questions. And then when I moved in the US and started learning more about these questions and all the theories that go behind it in my graduate studies, I was naturally incline towards this second group of people that don't like to be prohibited and like to continue drilling down onto this question. So I was fascinated by what gave this extremely unlikely universe and what was there before, and how did all the bits fit together into a coherent picture. When I got my faculty job in 2004 at the University of North Carolina in Chapel Hill, where I'm still as a professor there even now. I thought, okay, now I can afford to spend more time with this question. And I started thinking, how can I even ask, why did we start with this universe? If all I allow myself with is one universe, it doesn't make sense. If you have only one object in your pocket, it's meaningless to say, what is the chance that if I put my hand in my pocket, I'll pull out that object? Of course, it's 100%. It is the only object in your pocket.
You never tempted to go full Southern Baptist? There was a guy around who said, let there be light, and lo, there was light.
I have nothing to say about that part of the story.
Okay.
But so from a scientist point of view, I wanted to be able to calculate the answer and derive the answer, whatever the result was, even if the result was the same as what Roger had found in the 70s. So that way of thinking led me to figure out that the only way I can calculate and ask that question meaningfully is if I start with a pool of possible universes, infinite universes, from which then I can ask, what is the chance to start with this one rather than something else? I got lucky there because that was the year when string theorists ended up deriving from string theory, which is the underlying theory and the candidate of quantum gravity. But they had ended up finding out a pool of many possible potential Big Bangs that they coined the landscape of string theory. So all the pieces that I needed were there. I was prepared to address my question of the origin of our universe within a pool of possible Big Bangs. And there was string theory providing exactly that pool that I needed. Then I had the idea that in order to calculate, since the universe was very small at its infancy, I could calculate using quantum equations. That was the connection that I made between the
Could you hazard a moment and explain to people? Remember, when I was a child, the Big Bang itself was a bit of an outre theory. There were people advocating steady state, apart from creationism. So string theory was, 20 years ago, it was still sort of not quite pseudoscience, but it was on the event horizon for science. So is it well accepted now, and what is it if it is?
Well, the modern version of the Big Bang is cosmic inflation, and the two founding fathers are Alan Guth and Andre Linde, and absolutely it is accepted as the standard model of cosmology, because as I mentioned before, all the observations we have so far of the sky, all of them agree exquisitely well with that picture. And then remember that when we look far away in the sky with a telescope at a distant star, we're looking back in time, because it took time for the light of that star to reach us here on Earth. And therefore, whatever we are seeing today from that light was what happened to that star that gave that light, say 4 billion years ago or 5 billion years ago. So the further we see in the distance, the more we're looking back in time. And therefore, there is no doubt of what has happened to our universe over time, because we can actually see that with telescopes. We can't go, of course, we cannot see anything at the moment of creation. In fact, we can't see much on the first.
Well, we're back to fairly close with the latest telescope, aren't we?
Yeah, exactly. So
that's why 13.8 billion, I think,
yeah,
wasn't it?
Yeah. There is very little doubt on the standard model of cosmology being correct for what it explains from the moment that the universe starts growing to present day. but it is still an incomplete theory because it is based on that assumption of having a tiny patch of space full of high energies, and then that is put by hand. So the question is, what gave that?
Well, your breakthrough was to see tangible evidence. And we're talking about hypotheses that are proved or disproven by observations and facts, aren't we? So looking at the cosmic atlas, you discovered aberrations that could be explained by your theory of quantum entanglement before the Big Bang. Am I summarizing that properly?
Yes, we predicted that, and that's the work that I did with two collaborators, Tomo Takahashi and Rich Holman. We predicted, so as I was describing before, I had that idea of using quantum equations to actually calculate the chance that our universe came out of that landscape of energies. And therefore, I was able to extend, to complete that picture of cosmic inflation to from before the Big Bang, when when the whole universe was just a wave packet sitting on some energies in that landscape, to through the Big Bang when it explodes, and then it continues growing to now. That doesn't happen only to our universe. There is a whole family. In quantum mechanics, you always have a family of solutions that you find all the branches of the wave function. So there are many universes, many wave packets that go through a similar story to ours and go through their respective Big Bangs and produce their classically large universes. Somehow these universes have to decouple from each other when they are branches of the wave function. They are all quantum entangled to each other. So as they go through their
This is when we move from quantum
exactly to the Big Bang to growing large.
Newtonian, Einsteinian factors.
So once you grow large, then you are classical. The quantum nature is wiped out. But early on, we know we are quantum. So the universe is a wave packet, but so are all the other universes, and they are quantum entangled to each other. As they go through respective banks, they also have to start decoupling from each other. And that's done through something that is known as decoherence in physics. But this process, this decoupling, this decoherence, this wiping out, this washing out of quantum entanglement is done at the same time as the universe is going through cosmic inflation. And therefore, it leaves its traces, its dents, scars, the quantum fluctuations of that Big Bang, the exact same quantum fluctuations that later on produced structure and light in the universe. And since we had a complete story from before to through the Big Bang to after the Big Bang, we could follow the story of how quantum entanglement left its scar at the moment of decoupling and what that scar would look like today. We just fast forwarded everything, the whole story to present day. So we were able to make predictions for what those scars should look in our sky today. And that was done in 2005 and early 2006. One of the predictions that we ended up calculating, and in our case, everything was calculated. It wasn't guessed or hypothesized. But what we predicted was a very large area in the sky of about 10 degrees that should be completely empty of structure, of galaxies, stars, and so on. That breaks one of the cherished predictions of cosmic inflation, uniformity. In cosmic inflation, everything blows up uniformly like a balloon. So you expect a very uniform distribution of stars and galaxies throughout the sky.
Matter and energy, in fact.
Yeah. So predicting that there is an area of the sky, which is quite large, it's 10 degrees angle, that is empty. We call that the giant void. That was really a risky prediction at the time because it threatened the uniformity.
So you predicted it and then it was found, which must be a wonderful feeling.
Yes,
like Newton knew that apples fell from the tree. He didn't. He didn't have his theory, and then say, "Oh, look."
Yeah, exactly. And that was it was wonderful. Also, very shocking because we were pretty convinced that the kind of scars of signatures that we predicted in our sky would rule out the theory that we had come up with. So having them seen first by the WMAP experiment, satellite experiment, which is US-based, and then later on, that WMAP was replaced by the European Planck satellite experiment that had more refined data. And Planck satellite actually confirmed all those predictions that we had made in 2005. And that was in 2018 when they confirmed the existence of this giant void, which shows as a cold spot in temperature maps of the sky. Because of course, if you don't have a concentration of stuff, of matter, then it's a very cold area of the sky. So the cold spot is confirmed now at exactly the size of 10 degrees and the scale, the distance that we had estimated long ago. And then that gave us hope, because one of the prejudice against the whole study of the multiverse was the fact that even if there is such a thing as a multiverse out there, we will never be able to break free of the horizon of our universe and go and see what lies beyond. Unlike me, and that's the parallel that I use in the book. In Albania, we were closed inside the Albanian borders at that time in the communist era, and almost nobody could break free and see what is just on the other side of the Atlantic, very close, in Italy or in Greece. And now I was finding this situation where the whole universe is concerned, where we have this beautiful universe, we can explain what we see inside, but we are forbidden to see what's outside it because of the horizon of the universe, the speed of light limit. We couldn't go further than that. However, with our work, the one of the exciting findings was that when you calculate and you have a complete theory, you don't know whether the theory is right or wrong. You make a set of predictions for what scars of that multiverse should look like inside, in your sky, and then 10 or 15 years later, all those predictions are seen and confirmed. That, of course, is very reassuring, because it shows that although we can't travel outside the borders of our universe, we can still find traces of the multiverse right here. So we don't need to go to a time before the Big Bang or to break free of the boundaries of our universe.
Just to emphasize how cutting edge this is, we have to remember Albert Einstein himself referred to quantum entanglement as spooky action at a distance, and gave wonderful sayings like God does not play dice on the randomness of quantum events. So we've come a long way since then. Where, you're now sort of, you seem to have demonstrated satisfactorily, of course, waiting for somebody to disprove it, that we've got sort of echoes of before the Big Bang of the quantum wave function and the events. Now, you're referring to the multiverse here. Our vocabulary fails us a bit. You mentioned our perception of things. I mean, many of us are still trapped with the perception that an atom is like a solar system with a proton like the sun in the middle and electrons whizzing around like planets around it, when it sort of inhibits our thinking about the bigger things in the universe, and the idea of a wave and a particle being simultaneously the same thing. Have good luck to Schrodinger's cat. I don't like cats very much. I've often wished it ill. But that's a separate story. So, all of this is now pretty much accepted because it's been demonstrated, isn't it? So how do we describe, we think of the universe, the cosmos, as everything that exists. So we don't even have the vocabulary. You're talking about the multiverse. You're saying there's lots of universes. Or this is what's being hypothesized. And you seem to produce some evidence that right from the beginning. I mean, where is all of this? Can our minds take this in? Is there another word for, an ultra-cosmos that encompasses everything that we're thinking and talking about?
That's the multiverse, yeah. But was it Mark Twain that said the older I get, the smarter my father becomes? It's if you think about that, it's yeah, it might be mind-boggling when you think of the whole picture. It depends who you ask. If you ask me, I think it makes the cosmos more intricate and vastly more beautiful because it's more interesting. There is more stuff there. But if you think about it, it was only in the 1500s when Copernicus came up with the Copernican principle. So back then, we found it mind-boggling that the Earth is not the center of the solar system. And then we shifted that the galaxy, the Milky Way, is not the center of the universe. And now this is really just an extension of saying that our universe is not at the center of the cosmos, but we're just a humble member in its vastness. There is a vast, beautiful, interesting cosmos full of universes like ours out there, and we just occupy a humble corner in that cosmos.
I share your enthusiasm. I've been a lifelong science fiction fan, and I've had to reconcile myself to the fact that we're not going to go to the stars soon, based on current physics. And much as I like Captain Kirk and his colleagues, we ain't going to be sailing with them anytime soon. But you still have to, I mean, you sit back and you think of the scale of things between the microverse and the macroverse, the size of it. And I mean, don't you feel sometimes like you're a sort of a cell in pond scum trying to make sense of the world and the universe? Because the scale, when you look at the recent satellite pictures of the cosmos, the scale of it, the number of stars involved, it's just so mind-boggling. It's difficult not to be held back by your humbleness, as I think the word you used, by the humility of who the hell are we? Why are we bothering? Let's just lie back on the pond and scum along like the pond scum.
Yeah, well, absolutely. I mean, everybody that has children, you watch them show such surprise at their surroundings as they're growing, they're discovering all the objects, things that we take for granted, and there is beauty in that. I mean, that's the attraction of the innocence of that age. And if you just increase that scale by a little bit, in that sense, we are all children to the cosmos. And when it comes to the big questions, I may know a few more equations than you do, because that's what I do for a living, is use those equations in my work. But really, when it comes to the big questions, apart from a very limited set of tools that I may have compared to my neighbor next door, all of us are ignorant in understanding what is out there, but all of us share that curiosity, that childlike curiosity. So we are all children in that sense, when it comes to understanding the universe at the larger scales, and cosmos, and the global nature of space and time. I mean, we haven't even gotten into the question of time, which is fascinating by itself. But yeah, so I don't think of that of that curiosity in negative terms. I think it is one of the things that makes us humble as a species, less arrogant as a species. The fact that we know something, but it's not a whole lot. And also it makes us find common grounds to share that excitement of discovery and that curiosity that we all have about nature around us.
You discovered when you came here, and it must have been reminiscent of the University of Tirana and Enver Hoxha, that the scientific community has strong prejudices against people who rock the boat. The idea you came into a field and adopted what at the time was a fairly unpopular and not well proven set of assumptions, and I think you mentioned that you had advice to steer away from this if you wanted to make a career on it. It was a bit like advice to a budding chemist. No, phlostogen is not a good field to research.
Yeah.
So maybe you should try something else. So, I mean, how deep was that prejudice? Because we often find it that we think of scientists as being rational, objective, but quite often they can be fairly petty and stick to their theories. And you seem to have got the thin end of that on several occasions.
Yes, that's correct. I mean, and it's for various reasons. Some of it is prejudice against a set of orthodox beliefs in the field. Some of it is perhaps religious. When I mean, there is nothing related to religion one way or another in the work I do, but some people, short-sighted people, might see religious connotations to the interpretation of the results, which always surprises me. But so there are various reasons, and yes, academia is not safe from all the petty emotions that go with human nature. But that's where my the wisdom I learned from my father and the kind of survival tools that he shared with me come really handy. So in whatever I've done until now, and perhaps this puts me in a privileged position, because whatever I've done until now, I've just done it for the love of the subject, not because of some reward at the end of the line, not because I had any hopes of rocking the boat or making some big breakthrough. It was just that I love doing what I do, and I am lucky enough to have that kind of joy every day of my working life. And what I learned from my father is exactly take joy. Don't do something unless you don't love to do it. And the other part was all the resistance and the drama that might go with it. Just ignore it as background noise. Then it's not as dramatic and tragic as it seems to be. So far it has worked. It doesn't mean it will work in the future.
I think it was in your book, it might be something else I read recently, that it was mentioned that Newton, one of the pretty much undisputed giants of the era in terms of scientific breakthroughs, was, apart from being an alchemist, was actually so petty-minded that he basically made his predecessor, Robert Hooke, another no-mean physicist, a complete non-person. Removed all trace of him from the Royal Society, on presumably petty jealousy grounds. So, when we see the shoulders of giants, we often see a chip on them.
Yeah, it's funny you mentioned Newton. I just came back from Cambridge, and I visited. I saw his death mask at the university there at the Isaac Newton Institute of Astronomy. They have Newton's death mask, and it is quite spooky. It's a interesting experience. And then I arrive here, and I find in my office a big envelope, and somebody who had read my book and liked it had sent me the handwritten notes by Dirac, another giant of physics. So there is a wonderful feeling. In Newton's case, I don't know. The word is that they may have found he didn't really burn all of Robert Hooke's portraits and hadn't written notes. They may have resurfaced. So yes, Newton was known to be not so nice, but putting that part of being a physicist doesn't mean that you are a good person.
Albert Einstein didn't wear socks, but we forgive him.
Yeah, exactly. But focusing on their genius, on the legacy that they left behind for us, it is beautiful. It's you do feel walking, looking at their writings and what they discovered, and walking the streets that they walked. You do feel that influence, that you are walking on the steps of those giants. And it's a wonderful feeling.
If I were a commissar in the physics department at Tirana University, the question I might ask, and I'm quite likely the senator for North Carolina might say to, this is all very well. What can we do with it? How will it make money? What's the practical use? And I was thinking, as we've just discussed, 20 years ago, quantum physics and entanglement was spooky action at a distance. Lots of people are agnostic about it. And now they're building computers based on it.
Yes, and
a communication system. So, okay, you have managed to identify that there were contingent, tangential universes before the Big Bang. Can we call them?
Well, you can't have applied science without basic research. So without fundamental physics, you can't have applied physics. That's number one. It's when I am looking at a problem and I'm trying to solve that problem, I'm not thinking, how can I apply that to industry? However, I am absolutely certain that any discovery made in physics pretty soon will find this application in industry. Look at the Webb telescope. Some of the techniques that were invented for the mirror, for the folding of the mirror, are already being used, applied in eye surgery. And I give, or Einstein's theory. When Einstein was discovering his theory of gravity, he wasn't thinking of GPS, yet we are so rely on that GPS. We all use it when driving. And then it's based on Einstein's theory. I give the example in the book of Faraday. And in fact, I just came back, I gave a talk.
That's Michael Faraday, the British physicist.
Yes, I gave a talk 2 weeks ago at the Royal Institution, which is Faraday's old lab. And in fact, Faraday started this tradition of talks there. And I give the example of Faraday's, which is a true story in the book, in my book, where the minister, the equivalent minister of finance, the minister of Exchequer in Britain, went and visited Faraday's lab in that same place where I was giving a talk 2 weeks ago. And
oh, you mean the Chancellor of the Exchequer?
Yes, that's the one.
He's the money man.
Yes, and then he asked Faraday the exact same question as you just asked. He said, all of this is so impressive, but what it is good for? And of course, Faraday was one of the co-founders of electricity and a key figure along with Maxwell in unifying electricity and magnetism. So Faraday looked at him and he said, I don't know, sir, but I'm sure you'll tax it one day. And indeed, yes, we do pay for electricity.
In fact, Faraday in the north of England, where I was from, was famous not so much for his physics. We now use Faraday cages to insulate people from electromagnetic waves, but the Faraday lamp was the one that allowed miners to go into coal mines without blowing themselves up, because it insulated the flame from the methane gas. So, Faraday spanned both ends of the cosmos with this. Yeah. He was memorable and practical at the same time.
Yeah.
But you haven't got the funding to build any type of large hadron collider in UNC or anything like that.
No. No, we've got I can't remember, Amazon or Google or one of those big companies moving. I think it's safer than building a large hadron collider in Chapel.
You think? You could probably order one on Amazon. Whether they deliver it in time is another story. You can order anything else. So I suppose we may as well get back to parochial stuff. Has your work been translated into Albanian, either dialect, Geg or Tusk?
I don't know, but equations look the same in Albanian or in English. So I'm sure that interested students can read them. And Albania is a small country, and it shares many characteristics of small countries. Say, I don't know, other small nations. As a result of having a unique language, a very old language, and then being small, most Albanians speak English, Italian, some speak Greek, some speak Russian, so it's very well versed in foreign languages.
But a lot of works get translated into Albanian, though, don't they? Is this going to be translated?
I don't know. It's not up to me. It's Albanian publishing companies that will have to contact HarperCollins, the US publisher of the book. I know that it's translated in Greek. There was a one of the big publishing companies in Greece got it from HarperCollins, got the copyrights and for the Greek language translation, and this being translated in many other languages as well, in Netherlands and in Romania and in Poland and all over. Yeah, I don't know about Albania. They haven't mentioned that yet. The HarperCollins.
Well, it's no. I have to say, I read it and I read it quickly, straight through. It was I am by no means a mathematician or a physicist. It was a good read, and especially I admired your facility in writing about a subject like this without battering us over the head with raw mathematics, which I think is a rare skill, and the way you interwove the personal and the political and the cosmological. So I really recommend people to go out there, buy it, read it, and digest. And the bit we never touched is we discussed what might have happened before. Okay, your final, because we're closing. What happens at the end of the universe?
Nobody knows, because it will be dominated by the same type of energy as the one that created the universe. And since we don't still understand what that type of energy is that grows with the volume of the universe, then it can end either in a big crunch or in a big rip where the very fabric of space-time gets ripped apart. The big crunch would be where the whole universe crunches into a black hole, or quite likely it may end up in a cosmic heat death, a large universe that is completely empty, but it grows so large that it's empty and there are no structures allowed to be created in that universe. All the existing structures are diluted and far-flung. So that's the most boring and dreadful scenario. But that's the one that goes back to Einstein's cosmological constant. It's if dark energy that rules that end of the universe is the type of a vacuum, pure vacuum energy, the one that Einstein called the biggest blunder of his life, then we're all going to end up in a cosmic heat death, where the whole structure is wiped out and the universe is empty, cold, and dreadful for eternity.
I think that's the Hebrew version of hell. Sure, cold and empty. But look, thank you very much, Laura. It's been
thank you.
Illuminating. Once again, I really enjoyed the book, and it's, you know, Albania continues to surprise and introduce people like yourself to the world. It's it's a country that's how should I say, punches above its weight.
Thank you.
In the world.
And I heard, I haven't been back there for quite a while, but I heard it's absolutely beautiful there now.
Oh, it is. It's a beautiful country. I was working on a project there to encourage tourism, but some of my ideas were a little too much for them.
Thank you.
I won't put them on here. I'll get lynched. Okay, thank you very much indeed, and let us know about your future work, and when you discover the timing of the heat death of the universe, give us time to get out and switch universes.
Bye.
Thank you very much.
Thank you.
Everybody else, do follow. We have future briefings coming up next week. The newspaper access swaying the public towards Hitler's line. Newspaper proprietors have been consistent. The ones in 1939 were every bit as pernicious and evil as some of our major proprietors now. And you might notice the date, Thursday, September the 1st, was the start of World War II, at least from the British and French point of view. That's when they declared war on Germany. So it seems to be timely as we're sort of hovering around World War III at the moment as well. So please register, join the Foreign Press Association, get the details, and come soon. We'll see you. Thank you very much. Bye.